Y-axis, X would describe going horizontally, right? And Y would describe going vertically. And so in this first example, this is no different than what we did in Algebra 1 or 2, where we used this equation for Y, or the height equals, you don't have to write this down, I think you remember it. Okay. Well, the force of gravity was 32, so negative 1/2 times 32 was negative 16 t squared. Does this look more familiar? Okay. So, what this is a general formula that describes the height versus time of just its height versus time. So, this is negative 16 t squared. We hold that constant because that is the acceleration of gravity, okay? Do you remember what v sub 0 stands for? Initial velocity, and then h sub 0, initial height. And so what we did with this is we would put this into our calculator and we'd graph it and we'd see this parabola. And Mr. Staublin or whoever had, you had for algebra, hopefully told you that that parabola is just the graph of the height. It's not actually the movement of the object. Okay? So, to prove that, we're going to do this, and then I'm going to show you how you can put this in parametric mode. A distress flare is shot straight up. So, if something is shot, I know there might be wind, but if it's shot straight up, it's mostly going to come down, straight down, right? So hopefully it makes sense. The graph you're going to see is a parabola, that the graph isn't the flare. The graph is just a graph of its height. So this 75 feet above water is where it's shot from. That would be its initial height. And then its initial velocity is 76 feet per second. Okay. And so you don't have to do this. I'm going to just show you what we would do in algebra. We would go back to function mode. You're not going to do this. You're just going to watch. And we would put in then negative 16x squared plus 76x plus 75. Guys, stop talking. And we'd see a parabola show up. And then we could find different things, like, hey, what's the highest it gets? Well, we could find the maximum then, right? Okay. Well, when we just have vertical motion, how we're going to translate that to parametric mode is we have an x and a y, right? So what we're going to do is we're going to let x equal time t, and then we're going to let y equal this equation. So negative 16t squared plus 76t plus 75. Okay, do you understand why I put those things there? Or should I talk about that? This is the initial velocity, and in the problem I was told the initial velocity was 76, so that's why I put it there. And then the initial height was 75, which is why I put it there. Now, what your graphing calculator, here's the advantage of parametric mode. What it will let you do is it will let you stop time. Whereas on the function, we just saw the whole thing go, right? So what we can do is we can restrict the time, and we can graph it at 1 second, 2 seconds, 4 seconds, 5 seconds. So we're going to just do this on our calculator. So let's get out our calculators, and let's go back to parametric mode. And we're going to put our parametric equations in. T, negative 16t squared plus 76t plus 75. Okay, so what does t stand for? Time. So when I'm picking my window the first time, I'm going to only go from 0 to 1 because I want to simulate it for 1 second. So let's go to window. I'm going to go 0 to 1 second. What that will do is you're going to see just a little portion of the graph and it's going to stop at 1 second. Now, for Xmin and Xmax, what we have to remember is X is actually time, right? So in your head, you want to think about how long do you think a flare would be in the air for? Okay, should we start with 5 seconds? Okay. Then this flare is shot up. And it starts at 75 feet and it's going up from there. So what do you want to make the Y max? Okay, we can try 150 and then we can see if it's high enough. Alright, you ready? Alright, so what we see here is this is the flare for the first second. Alright, so how would I do then, do you think 2 seconds? Change T max to 2. Do you see it went up higher now? Alright, I probably need to change my Y max, don't I? I will go back to 300. How would I simulate 4 seconds then? T max again, except go up to 4. Okay, so we can tell now what's already happened. At 2 seconds it was still going up. Now it already reached its maximum and it's going down. Okay? And then I could do 5 seconds. And so on. Here's the thing about parametric mode. You can't, you know when we were graphing before, we can use the max button when we do second trace. In parametric mode, if you go to the calculate menu, they don't have any of that. You just have to use the trace button. Like if I said, hey, try to approximate the maximum height, I would just trace it. And I just try to get as close as I can. Like 165. Did it go above 165? Yeah. But that's as far as I could get. I can't do second calc and do a max because I'm not in function mode anymore. Okay. So, I really did this part already. We just did this stuff. Oh, we should do 1 second, 2 seconds. We'll go back and do it. At 2 seconds, trace back to 2 seconds. It was 163 feet. Let's trace back to 1 second. It was 135 feet. If I wanted to go 4 seconds, 123 feet, and then 55 feet. Okay, does that make sense so far? So that's if something's going straight up and down. Here's the cool thing about parametric mode. You might not think it's cool. I think it's cool. When you have something that's not going up and down, like in this next one, we're going to talk about Kevin hitting a baseball. And so when you hit a baseball, the baseball is moving out and up, right? So what we can do is we can actually look at the graph and have an equation for how is it moving horizontally and how is it moving vertically. The general equations for this are x is going to be v sub 0 times cosine theta t. So what's theta? Theta is just going to be the angle that it's hit at. And what's v sub 0 stand for? Okay. Would you also put a parenthesis on this so you realize that then you're going to multiply by t. T is not going to go with theta. You're not going to be taking the cosine of t. All right, then for vertically, it's similar. So we have negative 16t squared. That looks like what we saw before. We are going to do v sub 0 times sine of theta times t. Okay. And the reason why that works is because the velocity vector, do you guys remember when we did a vector and we said the components were magnitude times what? Cosine of the angle? Do you remember that? No? And then magnitude times sine of the angle? So this is review. That's why it translates to this, because isn't x horizontal? Now we're just modeling it with time. And then y, this part is telling us what part of the vector we're taking vertically. Alright, so we're going to set up our parametric equations for this example, and then I'm going to show you how you can put a thing. You don't have to. Alright,